Hello everyone, thank you for attending my talk. My name is Eilertsen. I'm a PhD student from University of Bergen and I will be presenting our work on refactoring tool usability. First, I'm going to introduce you to the problem of refactoring tool disuse. Then I will show you how we derive the definition of refactoring tool usability, which we then use to study user data from developers. I will focus on the insights that emerged from the user data, which we then use to refine our theory and to suggest implications for toolmakers. When we talk about tool disuse, we focus here on refactoring tools that are available in mainstream IDEs for object-oriented languages such as Java. So we see here the refactoring menu in IntelliJ. It comes with over 40 refactoring operations, just as Eclipse do. And we can invoke, for example, move, inline, and change signature here. And the tool is likely to perform it faster and more correctly than a developer who are manually making the same change. When developers do these kind of changes manually, they rely on less safe operations, such as search, cutting and pasting, compiler errors, and so on. Despite the benefits of using automated refactoring tools, developers mostly make such changes manually. Many studies have looked at the ratios between automated and manual refactoring applications, and across these studies, a persistent finding is that software developers perform more than half of refactorings manually instead of using refactoring tools. Now, of course, we want to know what we can do about that. So researchers also looked into factors that are prohibiting tool use. Here I list the papers we found that investigate either tool use ratios or such factors. And of course, some developers say, well, I've never heard of refactorings, or I never use IDEs, so I'm not aware of them and I can't use them. But developers also say, actually, I am aware of those tools, they are in my IDE, but I don't want to use them because I don't trust them. They disrupt my workflow or they are unpredictable. So this is interesting because there's clearly some potential for improvements here. But these factors are not well defined and therefore they're not easy to address with technical improvements. Especially this term trust is interesting. It comes up a lot, but it's sometimes conflated with predictability because it's unclear what it means. Is it referring to some kind of tool correctness, or is it referring to the developer's ability to predict and trust in their prediction what the tool is going to do? So these works indicate that disuse is a problem worth addressing, and they suggest that trust or predictability might be important terms to look for. Now, we want to help toolmakers address the problem of refactoring tool disuse, and we do so by providing them with a concise definition of usability of refactoring tools. We start with the ISO organization's definition of usability from their section of human-system interaction, and we operationalize it by, so to say, expanding the keywords based on recent research on tool use. So what is the system, what's the users, what are their goals, what's the context of use, and so on. And based on recent work, this is the definition we end up with. So you see here we have these usability factors: effective, efficient, and satisfying, that we are going to come back to. Our next step is to use this theory as a kind of lens to inspect our user data. And the user data we have available to us is from a user study that we performed. The full study is part of a different manuscript that's undergoing review somewhere else, so I will only briefly introduce it here. The study consists of 3 realistic software change tasks that are amenable to refactoring. What do we mean by that? So here's an example from task 2. Participants are told that there's a number of method pairs where each method in the pair is a negation of the other one. So here's one such pair: is all blank and is any not blank. And these pairs have been added between releases, so the client users of this code base have never seen them. And before the next release, it has been decided that we want to remove this double negated method and only keep the is all blank method, and this pattern applies to all of these pairs. So the task is to remove is any not blank and leave is all blank functioning the same way. And of course the trick is that the double negated method contains the implementation, and so it has to be inline into the other one, but we don't tell them that. We focus on the transcripts from this study, which capture think aloud audio recordings from all of the practitioners' work on the tasks, and audio from the subsequent interview segments that we conducted. This allows us to triangulate experiences that we find in the transcripts with what actually happened in the screen recordings. If a developer say that they had an experience, we can go and look at what actually happened. In order to approach these transcripts systematically, we develop a codebook. So you see here these 3 labels from our definition, these usability factors, and you see the 2 experience-related factors from related work, trust and predictable. So a codebook is simply a collection of labels and patterns to look for. So anytime you encounter the pattern in the transcript, you mark that segment of the transcript with a corresponding label. For a quick example, here's the participant 9 talking about a refactoring remove parameter that he applied in task 3, which introduced a compiler error, but the participant was satisfied nonetheless. So the interviewer summarizes, it broke the code, but it's what you expected, yes. So we mark it as predictable. He goes on to say it was more helpful than if it had rejected invocation. It was helpful, so we say satisfaction. He goes on to say it would have been an extra step to edit what he calls unrelated code. That's the code that triggered the warning. So we say this was an efficient tool. From the resulting data, we do a couple of different things, but I want to focus here on the card sort because it led us to these usability themes that are interesting. We created a set of cards, 1 set for each label. So here are the 3 cards that we created from the previous example statement, and we created 256 such cards, which we then put into Trello and did this card sort algorithm on. So the 2 authors jointly organized these cards within each set. They organized all of the cards in that set into groups based on their perceived similarities. And when once groups start emerging, we name the group and describe them based on the common themes in the cards that were contained in that group. So we do this across all sets, and we find 28 themes in total. For all of these themes, we take these little descriptive cards, so that's 28 cards across all of them, and we use them as the starting set for a final kind of meta card sort to identify higher level themes that apply across all sets. And this meta card sort result in these 4 usability themes you see on top. And so we see them here on the left-hand side. And on the right-hand side, you see the labels or the factors that each theme arise from. And in the middle you see our description of this theme. So in order to create our description, we had to go back. We had to go and look at the transcripts and look at the screen recordings and see what were actually happening here, what led the developers to having this experience. And from this, we deepened our understanding both of the themes and the problems that the developers had and of these factors. So we use this deepened understanding. We will use it later to both propose implications for the tool maker. So that is concrete examples of what could the tools have done instead that would have helped the developers, and we also use it to make a more concrete theory of tool usability. So starting from the top here, we noticed that developers need help understanding the tool's capabilities throughout many of their different interactions with it. And we see that this helps address predictability and it helps address satisfaction. What we're talking about then is for example, the tool's affordances. That's when a user wants to use the tool, they need to know when can they expect to be able to invoke it, how do they invoke it, and is there anything they have to do first, such as locating the right type of element or making a certain selection. For example, to use move method. Is it possible to select many methods and invoke move? So participants tried that and they failed because that invokes move class, which is not what they wanted. Or is it possible to first invoke move and then select methods from a dialog? So that's actually how you invoke move's static method. Or do you need to invoke it on the method declaration itself? So that's how you invoke instance method, which is what they wanted. And we didn't, when participants had problems with this, we didn't see any way that the tool would help them. Furthermore, if the tool identifies a precondition violation, it will often provide some error or warning, and of course these have to be intelligible, but they also need to communicate what the tool's capabilities are in that situation. We saw that even when developers understand the error message itself, they didn't understand what it meant to them as users of the tool. Does it mean that the tool can't proceed, or can it, but there's a risk of behavior change? This has to be communicated. We saw some developers immediately cancel their refactoring and actually tell us that the tool had said that it wasn't capable of continuing despite actually being capable, but they just, that's how they interpreted it. Whilst all the other developers, such as this participant 9, they continued, they introduced compiler errors, and they were very happy with that. And finally, a warning or error is often accompanied by some alternative action. So, for example, I can't actually move this instance method, but maybe you want to make it static and then move it. And there is no information about whether the tool is actually able to do that in a way that is equivalent to the original refactoring. So, again, that's something that the users might need help with, because we saw developers who misunderstood this and introduced behavioral changes in the code, which led them to just claim that the tool was unpredictable and they were unhappy. Secondly, the tool had to communicate the change. So this sounds like the tool has to have a preview window, and it has a preview window. And we saw that this was a problem, in fact, even when the developers interacted with the preview window before applying it. So even after looking at the preview view, once they hit apply or refactor, we heard developers exclaim, "What happened? Did anything change?" And what they then did was they actually resorted to either using git diff, or in some cases, and this is really experienced developers, they flip undo redo really fast to kind of visually recognize what changed in their code. As a kind of animation, as one person put it. This theme expresses the need for developer to remain in control of their code and to update their mental model. In some cases, this is especially a problem when the change occur across files. Because we saw that especially when a tool makes a change in a file that the developer is not yet thinking about, despite looking at the code changes in the preview view, they weren't really, I guess, mentally ready to interpret what that means until they are actually in that file and working on it. And at that point, it is no longer available to them, this preview window or the information about what the code did, the tool did, unless they go to git diff, and at that point the change is probably going to be mixed with other changes. And of course they can't easily revert it at that point. So thirdly, developers want actually not just to be aware of the changes, but in some cases they want to guide it. So we see that this triggers on all the factors actually, and it's something that came up a lot. Developers want to be able to, for example, apply the refactoring to many elements. So they want to be able to move many methods at the same time, or they want to exclude the application to some locations in the code, for example, excluding test files, and they don't necessarily want to introduce compiler errors there. So maybe they want to keep the tests running while they change the functional code and then move to the tests later, or they want to make readability changes in each location now is changed. And finally, they need help assessing the cost and benefit of using the tool compared to using their manual approach. So we bring these topics back into our usability definition. We flesh it out. This is all in the paper, go check it out. Same with the implications for toolmakers. We think these are really neat and insightful, and we think that if toolmakers create tools that address these topics, they might become nicer for developers to use, and they might become more used.